right. Hello and welcome to our event. My name is Violeta. I'm a digital adoption manager. And today I have the pleasure to say that we are broadcasting this event from the Oracle Solution Center in Bucharest, which is, by the way, the biggest one in EMEA region. The Oracle Solution Center is an Oracle division that offers customers the opportunity to test and validate complex architectures based on our technologies. As you could see behind us stand these beauties Exadata and Spark servers, and soon to come is the S11. Oracle has 4 Oracle Solution Centers globally. One of the biggest one that we have in EMEA is the one in Bucharest. There is another one that stands within the UK region in Reading, one more in the US, and another one in Japan. As far as I know, here at OSC, our colleagues are constantly investing in the newest equipment. So if you are around, please contact your account team and visit us. Now, going back to our event, today you will see AI vector search and Oracle machine learning products. And Emma, here with us, has built a very cool demo on how to enhance job matching and employee attachment. Emma, would you like to say hello?
Yes, hello everyone. Hi Violeta, it's really great to be back in the developer coaching sessions with you. And in this lovely location in Oracle Solution Center, it's really a great vibe, and it's really nice to see where the actual magic happens behind the...
That's right. Okay, Emma, I see that you have a box here. Can you explain us what it is?
Yeah, we are actually talking about OCI, or Oracle Cloud Infrastructure Roving Edge, which accelerates the deployment of the cloud workloads outside the data center. As you can see, it's a rugged device that it really works in disconnected locations. So, for example, if you use OCI out of the data center, you could use it using the roving edge. And it can also process AI and ML workloads. So today we will take a look at how we can use vector search and similarity search capabilities within the Oracle Database 23 AI and Oracle machine learning as well to take advantage of our unstructured data in a use case around enhancing job matching and employee attachment. Before going into the actual presentation and demo, just note on the safe harbor statement. Basically, for today, what I would like to do is tell you more about the demo inspiration and let's say the target personas from the business perspective for our use case, what we have used behind the scenes, and then the actual demo. So in this demo, we have the case of a large multinational corporation that has multiple job openings across different departments and locations, and the company faces challenges in efficiently matching employees to suitable job openings, which will lead to prolonged vacancies or employee dissatisfaction and, of course, higher turnover rates. So the human resources department wants to, improve the job matching and enhance employee attachment by leveraging the AI and ML technologies. So as a target personas, we have the HR manager that would like to better understand if there are any similarities in job openings so that the same candidate can fit into multiple jobs. He also wants to, retain valuable employees with rotation possibilities, which are aligned with their career aspirations. And the data scientist who would like to build a platform to search similar CVs and to combine the information with employee attrition possibilities to provide actionable insights to HR manager. Basically, this is what we will see in this demo, okay? Now, behind the scenes, we have used technologies that we have in the Oracle Cloud infrastructure, and this is what you see here. Basically, it offers everything you need for your workloads from infrastructure, either compute or storage or networking, integration and data management, and last but not least, the AI ML platform. For today's demo, I have used OCI data science, which was used to orchestrate everything. Then Oracle machine learning in the database, and the newest AI vector search capability in the Oracle database. I've also used the Oracle Analytics Cloud to showcase the end business results, to business users, basically. And in case you're not familiar with the services, OCI Data Science, it's a collaborative platform for teams of data scientists to work together on the end-to-end data science lifecycle, from model development in Python open source code, or also using the accelerated data science kit to also model deployment and machine learning operations. So basically, the end-to-end data science lifecycle can be covered here. When we talk about Oracle machine learning, we think about in-database machine learning capabilities. In this case, data resides in the database. You don't need to move the data, and the algorithms will run on top of the database, offering enhanced performance. And the last but not least, the AI vector search, which is the latest addition to Oracle Database 23 AI, which is used for similarity search. And you can query business data alongside vector embeddings. Now, let's say, I think it's enough with slides, and we will go to demo. I just want to show you, before we look into how we put this demo together, I would like to have a look at how an end user would actually use an end application. And basically, just a second. Okay. So basically, in the role of the HR manager, I would like to understand similarities in job openings so that same candidate can fit into, into multiple jobs. For example, for data scientist vacancy, just a second. For the data scientist vacancy, what would be the other similar job descriptions in the system required by other divisions? So here in the front-end application, I have the possibility to upload, a document with the job description, for example, in this case, for an AI specialist. And when I hit submit, what it will do, it will retrieve for me the top 3 matching job descriptions. And I can see the first result, and the first match is a data scientist. The second one is a business intelligence specialist. And the third one is a CRM analyst. Now, let me switch to my environment to actually show you how we can do that. So what you can see here is OCI data science. And basically, as a data scientist, I can use OCI data science to actually build what happens behind the scenes when we upload that job description and we get the similarities. What you see here in the home page is the launcher tab, where I have shortcuts or extensions to various, let's say, functionalities in OCI data science. For example, AI quick actions, where I can test and deploy and even fine-tune foundation models with AI quick actions. Then I have the Environment Explorer, where I can explore and manage Conda environments, like, for example, when I want to build a model using, for example, for deep learning, I would need to use GPUs, like, the ones we have here in the data center. And then I also have the Notebook Explorer, where you could see notebook examples with explanations and code example of how you could use OCI data science, which is a really, really good starting point for you to learn how to use it in case your journey with OCI data science is just starting. And if I go to the actual notebook, where I'm basically orchestrating everything and doing the embeddings and everything else, I will walk you through it step by step. Basically, I'm importing all the libraries that I need. You see here Pandas, NumPy, also Gradio to build that app that you have just seen. Then from the LangChain community, everything that I need for my model, and so on and so forth. And then moving forward, I need to copy my documents, and let me show you how this looks like. So behind the scenes, I have these Word documents with job descriptions, and let me just open one of them and share it with you. So this is the job description for AI specialist. You can see the job description, the responsibilities, and the skills. So basically, I have similar job descriptions and job descriptions which are not similar to my, if you like, the job description that I've tested. And this was the split done just for my reference. But when you load the documents, you load them all at the same time without making the difference between similar or not similar, because we don't know the difference, but we will get it through AI vector search. So there are some prerequisites that I need, and they are all here. Basically, we need to copy the documents to the database server, and it's all detailed here. We need to have a document loader directory. Then we need to copy. I've archived all my documents in a zip file and copy that to the database server. Now you won't see my details because I've just kept the host and IP address like placeholder for those. You will need to fill in your connection details, and then basically copy all the documents into the database. Then what we need to do is to configure the database to read the documents. And again, you see here all the details. These prerequisites, what's nice is they need to be done one time, and then you can copy your documents whenever you need. The next step is to connect to the database. And again, you can see I'm establishing the connection to Oracle database and then loading the document to the database. You can see here, I'm just creating a table where I will store my documents. And you see an ID, the file name, and the actual data from each file name. And then I'm just executing this piece of PL SQL code to load in the documents. And you see my 6 documents, which I've mentioned here. Then I just execute the SQL to get the count of my data, and it retrieved for me 6 documents, basically. When the next step is to load the embedding model to the database, and I'm using an Onyx format embedding model. You can see this is what it does in this PL SQL procedure. Maybe I'll move forward and show you the actual PL SQL to load it. Okay, and I've used this model all mini LM L6 version 2. The load has been done successfully. Now this has been run in advance, but when you will fill in your connection details, you will be able to run it yourself as well. And the next step is to convert the documents to text. Basically, I need to give some parameters for the document store loader, the username, and then the table name where I want to load. And this is where it will, from here, it will read the documents, convert them to blob, the blob documents, to CLOB documents, to extract the text into lists. And then what we can do is to clean our text, to basically remove everything which is, let's say, words which are not nice to use. We can also remove extra spaces at the beginning, at the end. We can make replacements to, replace any text or any comma or anything that we don't need, and remove extra spaces in order to have a clean text to be then embedded and transformed into vectors. Okay. And then if the text is long, it can be split into smaller chunks, then embed and store the chunks into a new table. And this is what this piece of code does. And finally, we store the chunks into the new table. And once we have that, we can create the vector indexes. And you see here, I'm specifying some parameters, which is the model and some other parameters. I've used the default ones, but you can change them definitely. And then we can see how vector searching might look like. We can define a search query like, for example, I'm looking for a person skilled in machine learning and AI. And when it will perform the similarity search, it will return some answers, top 3 answers. And you can see how this look like. You can see here the metadata for my answer. And this answer is coming from AI specialist document. I've been doing some more tests here. We can also specify when we want to test the output, we can specify to display the relevance score as well. Basically, it will show top 3 results with the highest relevance score. And you can see data scientist is the top relevance score with 0.5. And the next one is AI specialist with 0.44. And so on. You can do many tests. You can create your own prompt and you can test and see how this works for you. Then you can, what we can do is we can integrate with OCI generative AI services, which this is something I didn't mention, but this is our generative AI service, which allows you to basically generate answers and improve your similarity search with the generated answer and enriched answer, basically. I'll just show you how the result looks like. So if I have this query, I'm looking for a person skilled in machine learning and AI, it will give you an answer. Okay. Then the last step is to build a RAG application like the one that you have seen. It's just a simple one that will enable you to upload a job description and then get the top 3 similarities in the same interface. This is the part which orchestrates, let's say, the, if you like, the similarity search. If we move next, and let me switch to Oracle machine learning. My session just expired, so just give me a minute to log in. Okay. So basically, after identifying similar job openings, before recommending to external candidates, the HR department or the HR manager might want to plan to understand the churn potential of the current workforce and basically to inform the existing employees about opportunities that align closely with their current roles. And this will support their skill development and contribute to higher retention rates. The HR manager asked our data scientists, if we come back to our scenario, the HR manager asks to the data scientist to develop a machine learning model to predict employee attrition rates. And if I'm back in the role of the data scientist, I can use Oracle machine learning within the database, within the Oracle database, in order to get those predictions. Now, what you see here is exactly the homepage for Oracle machine learning. And as a data scientist, I have 2 options here. Either to go to notebooks, this is Zeppelin notebook in Oracle machine learning, and I can start writing code and do my predictions, or I can use the AutoML to create and run what we call experiments. And I have here an AutoML experiment, and I will show you how it's created. So basically, when you want to create a new experiment, the data is already residing in the database. As I mentioned, this is a must-have for you to be able to use Oracle machine learning and run machine learning on top of your data. So what I need to do is just give a name to my experiment. Then I can type in a comment as well, and then I need to select my data source. In my case, I have a table which is called attrition training. And basically, attrition training contains all this information about my employees, like the job role, if they do or if they did overtime, what is the total working years with the company, what's their age, in what department they are working, the monthly income, education, a lot of information about my employees, right? Many information. So once I select the data source, I need to tell my experiment what is it that I want to predict. In my case, it's what I want to predict is whether the employee will leave the company or not. So it's basically a matter or a problem, a classification problem, a binary classification problem, where I want to predict yes or no, employee will leave or not. Okay, and the column which contains this information for my historical data is the attrition. Now the prediction type is classification. For the AutoML experiments, we can have classification or regression. In case you want to have other type of machine learning models, you can definitely write code. But for today, I just wanted to show you how you can quickly experiment with your data without actually writing code. And then I need to select the case ID or the primary key of my table. One other thing to mention here, in the data science lifecycle, we have various steps, and part of the steps are the data exploration and then data preparation and feature engineering. This part was previously done in a notebook, or if you like, in the database. The table that I've imported here, attrition training, contains the data already prepared. Okay. There are additional settings that I can do. I can select the number of models to be tested, for how long the training should last, the database service level, and this depending on the way I want to allocate resources. I can have low, medium, or high, whether I want the compute to be done in parallel or in serial, and so on. And then the model metric that I want to use to monitor the model performance. In my case, I've just selected accuracy. But you will see that we will be able to also check other model metrics once we have the results. And then we can have, we can select the features or the columns that we want to use in our experiment. In case you think there are columns or features which are highly correlated, you can exclude one of them. And once this is done, I can start running my experiment, either to get faster results or better accuracy. When we select faster results, it will run for shorter amount of time, but the results might not be as accurate as if we would run the experiment for better accuracy. But in that case, the duration time, the training time might take longer. Once this is done, and this is the execution is completed, I can check all the steps that my experiment followed. And this is basically something that AutoML does in the background. You can see the algorithm selection is done automatically, the adaptive sampling of my data set. It will also select the features, the most important features that will, influence the prediction, and then it will tune the models, all the models that I've selected to be tested, one by one. And then the feature prediction impact will also be calculated. And all these results can be seen in this leaderboard, where I have for each algorithm the accuracy that I've wanted to use as a metric to monitor the performance, but other metrics as well. If I click, for example, on this one, which looks like the top performance, if I'm looking at the accuracy, I can see the prediction impact or the features which are the ones impacting the most the predictions. And I see over time and environment satisfactions are impacting the most my predictions. I have other features as well, but these are the two most important. I can also check the confusion metrics and see, verify the actual versus predicted values. And this basically reflects my accuracy as well. One more thing I can do here is deploy my model. So if I click on deploy, let's say I'm happy with the results. If I deploy my model here, I just need to specify a unique alphanumeric string, and let's say it's the same version. This is already in use because I've already deployed it actually. Let's say this is version 2. And if I click on shared, my model will be deployed and it will be available for consumption in Oracle Analytics Cloud. I will click on cancel here because I've already deployed it. And I will show you how the integration with Oracle Analytics Cloud is done. But before that, one more thing I want to show you is you can create a notebook that will, if you click on create notebook, it will automatically generate a notebook with the code needed to, create the model, build the model, and then train the model and score the model for results, or inference the model. And this is how it looks like. So it was really at the speed of thought, I could say, used or generated. And you can see here how this looks like. You can get the proxy objects or the data you want to use for building the model. Then it will prepare the training and the test data for you. It will build the model, in our case, a sport vector machine. And then at the end, it will score the data. So if we run this, we will get results. Okay. It will take a while now. I won't spend too much time on this. But let me go to Oracle Analytics Cloud and show you how this looks like. Okay, this one also expired. Just a second. One more thing I wanted to mention in Oracle Machine Learning is Python users can now really easily activate GPU resources at the individual notebook level and basically leverage the GPU-enabled Python packages. This feature supports the use of GPUs for compute-intensive tasks on the Oracle Autonomous Database serverless with the Oracle Database 23 AI. You just need to select from the notebook setting to use GPU, and basically the resources will be activated again from a data center like the one that you see today. And once I have the predictions of the employees that are highly likely to leave the company, I can make the model available. And this is just a one-time registration done by an administrator who can register the models which are deployed into production in Oracle machine learning. So if I connect to my database, you can see here all the models which are deployed into productions and built in Oracle machine learning. So if I click on one of them, you can see how this looks like, information about my model. It's a classification model. It uses a decision tree, and I can see what are the input columns, which are the output columns. And for a classification, for example, I see the prediction, whether an employee will leave or not, and the prediction probability, how confident the model is about the prediction. And you just click on register and the model will be available in Oracle Analytics Cloud. Now, using a data flow, you can actually use the model for inference, and then the results can be shown in a dashboard like this one, for example. Okay, just let's see how this looks like. So we can see information like the attrition rate, how many employees we have, and how many employees left the company for my historical data, of course. And then I can see the predictions. For example, I see that 14% of the human resources department employees were predicted to highly likely to leave the company, and 9% of the research and development department, for example. We can also see the prediction by job role and by gender or by salary hike, and so on and so forth. If we look at the prediction by job role, we can see that the data scientists and let's say business intelligence specialists are highly likely to churn. So if we remember, these are two job descriptions which are similar to AI specialists. So, for example, if I select the data scientist, the ones with high churn potential, I can see in the table, and maybe actually let me filter. If I right click and click on keep selected, it will filter my dashboard for data scientists, and I can see the details of the data scientists who were predicted as highly likely to churn. And I can see in this table more information about my employees. For example, the first one is in the research and development department, and is predicted to highly likely to leave the company with a prediction probability of 89%, so quite high. So in this case, I can inform all my data scientists in this table about opportunities that might align closely with their current roles. And this will support their skill development and basically contribute to higher retention rates. So in the role of the HR manager, what I could do is I can send similar job openings to the internal candidates with high churn potential. And let's say after seeing this announcement, an internal candidate applies to business intelligence, to AI specialist role, and he or she is successfully selected. So in this case, HR is happy to retain the valuable employees with rotation possibilities, and the employees are also happy that they can rotate and develop their career furthermore. That's all from my side for today, Violetta.
Yes, thank you, Emma, for the great demo. There is one question that I would like to share with you, actually. It's coming from Paul, so I think it was raised at the start of your demo.
Mm-hmm.
Interesting how for AI analysts, the system did get back with job profiles like constructionalist and graphic designer. Is it that based on some rules which probably were wrongly set? Is there a way to see the accuracy of the model with time and monitor it?
Yeah, thank you for the question, Paul. So it was an AI specialist, and if I remember well, the similarities were data scientists and BI specialists. And what we can check is that relevance score. It will return the top 3 relevance scores for the similarities that the model found. So this is something that I think we could use and improve it. There was no other, if you can show me again the question, there was no other...
Sure. 1 second.
Yeah, we didn't use any other rules to, get the results. It was just we took the descriptions, job descriptions, we have embedded the text, and then AI vector search did the similarity search based on the default is the Euclidean distance used, but you could use other distances as well. So this was basically the rule, if you like, but it's not something that I've changed, but just use the default Euclidean distance. Basically, if the distance is closer or shorter, then those two are similar. If the distance is higher, then they will not be as similar. If we can call that a group. I hope I answered your question.
Thank you, Emma. There is somebody else who is asking to download the use case and use within the on-premises. Could you please give us the link for that? Would you be able to share?
We need to check. I'm sure that the recording will be posted on YouTube. We need to check if we can share or how we can share the other assets. And yes, it can be. The AI vector search is also available on the Oracle Database 23AI on-premise.
Thank you, Emma. All right. So,
Violetta, just before you start, Emma, there was a few people, I think, in chat. Pretty sure I saw a few in chat, and there was one person, I think, on Q&A looking for a copy of the code.
Copy of the code.
Yeah, we need to check that. Yeah.
We need to check if we can share Tom. So we will do a follow-up, I would say, with the ones who were interested in getting the code on Slack. So feel free to join us and then just raise a DM or put a question on the channel, and either myself or the team or Emma would come back to you. Yeah. And regarding the possibility to actually talk again with Emma in a private call this time, we do offer this possibility. So as we speak, I just posted on the public Slack channel where we invited you all to join us, that the developer coaching boost call with Emma is registration is open. So the first two customers that will reply to this message that I just posted will be contacted by us, and we will organize a 20 minutes call that you can benefit from it and chat privately with Emma, whether you have, I don't know, a particular use case or you would like to get more insights about the topic that we covered. So keep in mind that this cannot be replacing any of the current workload discussions that you might have with Oracle. And of course, it is not meant to be a support call. So if you'd like to chat with Emma, feel free to message us on Slack on the post that you saw now from me, and we will contact you. Now, Emma, would you like to say anything else?
Just wanted to mention, we also have live labs that everyone can use. There is code example in there. We will share it on the Slack channel.
Yes.
And perhaps also add it on the slides.
Yeah, we can add it also on the resources side. All right. Thank you all for joining us today. We hope to see you in the next one. Enjoy the rest of the afternoon and take care. Bye-bye.
Bye.